To begin our journey into relational algebra, let's first talk about some basic and fundamental concepts. The two fundamental concepts in relational algebra are relations, which represent the information or the data that we're storing, as well as their structure, and various operations which allow us to find the data stored in a relation, transform relations into new relations, and to add and remove information to relations and from relations. And we'll see how all of these work as we proceed. So first, the fundamental concept of a relation. A relation is defined mathematically as a set of tuples, each with associated attributes. So we can think of it, if we think of a spreadsheet table or a database table, we can think of each row represents a tuple, which is information about one thing. So in this particular example, we have a set of banking transactions. Each transaction is represented on one row as a tuple with 5 pieces of information: a transaction ID, identifying the transaction uniquely, an account ID, identifying which account the transaction was made against, the type of transaction, whether it was a deposit or withdrawal, the amount, and the date of the transaction. Now, each of these attributes, represented here on the columns, transaction ID, account ID, type, and amount, and so forth, has a domain, which is its set of possible values. You can think of the domain as something like a type in programming languages. Different attributes will have different domains. So for example, amount, the domain are numbers representing amounts of money. Similarly, the type can be either a withdrawal or a deposit as a string. The date attribute, its values are dates. It's important to note that in any specific relation, all tuples have the same number of attributes. So the relation, the structure of the relation rather, is defined by the attributes that it contains. Now, it's important to note that all the tuples in a given relation have exactly the same number of attributes. So the relation itself defines the attributes, and every tuple within it has a value for each of those attributes. So when we talk about a relation being a set of tuples, let's now take this same example and rewrite it in set notation. So in set notation, we have a set comprising 5 ordered 5 tuples, each one with 5 elements of information: the transaction ID, the account ID, whether it's a deposit or withdrawal, the amount of money, and the date. And we now see it in a set notation. Now, one of the things to note here, and we'll come back to this, is there never can be 2 identical tuples within a relation because it's a set. Sets don't contain duplicates. And this will be important as we continue. Since any given relation has a specific set of attributes, each with its particular associated domain, it has what's called a relation schema, which gives the set of attributes in the relation and defines what they are. So in this case, our transactions relation, which stores information about all of these transactions, has 5 attributes: transaction ID, account ID, type, amount, and date, each defined as given here on the slide. And every single tuple in the relation must adhere to this schema. So we can also enhance the schema by showing the specific type and domain of each of the attributes. So for example, a transaction ID is an integer, an account ID is an integer, the type is a string restricted to just the string deposit or the string withdrawal, the amount is a floating point number, and the date is of type date. We may also want to show in the relation schema which attributes are keys. So for example, here in the transactions relation, the transaction ID therefore constitutes a primary key for the relation because it is unique to each specific tuple. We also can show that the account ID is a foreign key. It's a key into a different relation, the accounts relation, which has a unique account ID for every particular account in the banking system. So we show that there's a primary key and there's also a foreign key which references a different relation. These are going to become important when we want to query our data and update our data, as we will see. Now that we have our fundamental concepts under our belts, let's dive in and see what kind of operations we can do on these relations to do really interesting things with our data.